Hello, how are you? What's going on? So this week is meteors, meteorites, meteoroids, asteroids, and comets. So basically anything from the asteroid belt all the way out to the Oort cloud, including the Kuiper belt somewhere in between those two. So they're just rocky bodies. They're just ice and rocks and chunks of stuff flying around the sun, and they're just big chunks of stone. There's not a whole lot to them there, except for the comets. There's some pretty interesting things about comets. But on the test, the most important part, what's the difference between a meteor, a meteorite, and a meteoroid? So the meteor, Latin root for in the atmosphere, through the atmosphere, consisting of atmosphere. You can't just say that meteorology, that sort of thing, means air. That's not what it means. You can't just say sky, because that's not what it means. It means anything involving the pocket of air surrounding the Earth that we live in. And so meteors enter the atmosphere, but they don't hit the ground. So they go through the atmosphere. Meteorology, the study of anything moving through the atmosphere or how the atmosphere moves, that's meteorology, which we covered. We studied meteorology for 4 or 5 weeks earlier this year. So meteors enter the atmosphere but do not hit the ground. You need to know that one. Meteorites are the ones that hit the ground, because those ones you can go pick up, and I'd like to show you my meteorite collection. There's like 3 or 4 of them about this big. They're not real impressive, but they're cool looking. I mean, the fact that they're from outer space is cool. And best place to go look for meteorites is surprisingly Antarctica, because it's all white and meteorites are very, very black. And so you look out on the ice and go, oh, there's one. Hey, there's another one over there. And you can find the reason the Arctic is not good for finding meteorites is because there's no land under it and the ice moves. And since the ice moves, it changes every year. The ice in the Arctic changes every year. The ice in Antarctica is sitting on a giant landmass with mountains holding it kind of in place. And if a meteorite hits there, it'll just sit there on the surface of the ice for decades and just not change at all. Some of them get covered by snow, but some of them just sit there on the top. So meteors move through the atmosphere but don't hit the ground. They burn up in the atmosphere, turn to ash before they touch the ground. Meteorites hit the ground, or in one case, a dog in Egypt, or in another case, a trailer in the middle of the Australian outback. Both have gotten hit by meteorites, and yeah. And then a meteoroid. A meteoroid just shouldn't have the word meteor associated with it, but because it's similar to meteorites and meteors, it's called a meteoroid. A meteoroid is going to go past the Earth and not enter the atmosphere. And so that's a meteoroid. If it doesn't go past the Earth, it becomes asteroid. It's a different word. So asteroids don't come close to the Earth, and they're in orbit around the sun somewhere. But if they're close to the Earth and of small size, that's meteoroid. Asteroids come close to the Earth all the time, and the really big ones, you just call them asteroids. You don't call them meteoroids because they're just really huge. And really large ones pass the Earth all the time. In fact, some of them go between the Earth and the Moon, but that's 258,000 miles of space between the Earth and the Moon. There's plenty of room for a city-sized asteroid to go right between those and never even bother the Earth. It doesn't even phase us. It doesn't even tear any satellites out of orbit or mess with the weather or anything. And so asteroids, a big chunk of rock, usually not round, but in the case of Ceres or Eros or the other ones that are big enough, they get a rounded shape because of their gravity. And so you've got, let's see, meteors, meteorites, meteoroids, asteroids. You find asteroids between Jupiter and Mars in the asteroid belt, and it is nothing like the cinematic asteroid belts you see on TV. Star Wars asteroid fields are unrealistically dense. If you see an asteroid, if you're standing on an asteroid and you see another asteroid, it's going to be 2, 3, 5 miles that way, maybe 100 miles this way. And if there is one above you or below you, it's going to be thousands of miles away. It's just, they're not that close together. The asteroids aren't near each other like they are in the movies. But Star Wars is still really cool when they shoot through the asteroids and, almost get killed. So then you have the Kuiper Belt, which is past Pluto's orbit, and it's part of Pluto's orbit. Pluto's orbit goes through the Kuiper Belt every time it goes around, and that was on our last video. The Kuiper Belt is made of big rocks, chunks of ice, a bunch of gases, mostly frozen. It's very, very cold out there. The Kuiper Belt is the home of a bunch of comets, and the comets come towards the sun and then go back out to the Kuiper Belt, just like Pluto does. It gets closer to the sun and back out to the Kuiper Belt in a 200 to 300 year cycle. Some of them it's a 1,000-year cycle. Halley's Comet, I can't remember the number. I'm gonna make up a number, and then I'm gonna find out if I'm right or wrong, and I'm gonna try and remember to put the number up here. 75 years? I don't know. Let's go find out how often Halley's Comet shows up. But there are several Hale-Bopp comets, and I mentioned Hale-Bopp before. Mr. Hale and Mr. Bopp are both astronomers. They work together. They discover a lot of comets in their work. It's not all they do. It's not their exclusive job to discover comets, but they've discovered a lot of comets. And so there's a whole bunch of Hale-Bopp comets named Hale-Bopp 1, 2, 3, 4, 5, 6, 7, 8, 9, 25. I don't even know how many there are. And so they come, past the sun. As a comet passes the sun, its icy particles start to melt, and it leaves a kind of a trail behind, and that's why comets have tails. And so there's two tails for a comet. The particles that fall off and get left behind follow the comet as its path goes around the sun, but the solar wind blows on some of those. And so you have your comet and you've got your tail behind it, but then the sun blows some of it off this way, and so you get a split tail, kind of like in Sonic, where you got the fox with the two tails. That's yeah. And so it's got, some of them have two tails, but only when they're close to the sun. When they go back into the Kuiper Belt, they freeze solid again, and they're just frozen chunks of ice and rock. And so really, what we call them is dirty snowballs. Comets are just dirty snowballs. And so we landed a probe on one of the comets that was going around the sun. It had a tail at the time, so all of those icy parts were evaporating and falling off the back of the comet as it traveled past the sun. And so we figured out what chemicals are in there. There's water, ice, methane ice, alcohol ice, frozen alcohol, amino acids, and other complex chemicals. And so comets actually carry around the building blocks of proteins through the solar system. And other solar systems probably have the same thing, because our solar system was made from a supernova explosion. There's no reason the same materials didn't end up in other solar systems. So whatever planets got blown apart during the supernova that created our solar system had amino acids on them, and those amino acids are now drifting around the universe. And so life could have been, not life, I guess I'll say that differently. Amino acids, which could build up into life in the right conditions, have been delivered to every planet in the solar system and other solar systems. But do those planets and other solar systems have just the right conditions to have life? Do they have a liquid for the amino acids to perform chemical reactions in? Do they have the right temperatures? Do they have the right gravity, sunlight, etc.? Energy sources of some kind. It doesn't necessarily mean sunlight, but there are life forms that live without sunlight on this planet under the ocean, but sunlight's a great source of energy for life forms. So anyway, comets could have been the way life was delivered to the planets, or a predecessor to life anyway. So you got meteor, meteorite, meteoroid, asteroid, comets, the Kuiper Belt, the asteroid belt, the Oort cloud. The Oort cloud is big chunks of rocks and ice surrounding the solar system, but it's not the outside of the solar system. Voyager 1 went off towards the planets and out, but it kind of took a wrong turn. It kind of went, ooh, no, wait, I got too close to the gravity of one of the planets, and it ended up going up compared to the solar system. And so Voyager 1 has been turned around and pointed back down to the solar system, and we've gotten some pictures of what the solar system kind of looks like from Voyager 1. Voyager 2 went out past the planets and kept going out, which the direction along the plane of the planets, and it just kept going. And so it has gone through the Oort cloud and discovered a sphere around the Oort cloud made of magnetic fields caused by our sun, and that's called the magnetosphere, and it's not through that yet. Maybe once it gets past that, it will be outside our solar system, but it has to get to a point where there are objects not orbiting our sun, orbiting other stars, and as soon as it finds one of those objects, then it's outside our solar system. But it's been going for 40 years. Voyager 1 and 2 were supposed to last 20 years. They're nuclear power cored. Basically, it's a cell phone with a nuclear power supply. They have this exact technology right here. This technology is in Voyager 1973. These had already been invented. This camera had already been invented. It's been improved. The ones on Voyager 1 and 2 are black and white cameras. But this camera right here, the ability to take a picture digitally and send it back to Earth on a radio signal, that's a cell phone technology, and it uses the exact same transmitter types, exact same frequencies. That was invented in 1973-74. Well, sorry, it was used in those probes in 1973 and 74, and their nuclear power core that were supposed to last 20 years, those power cores have been running 40-something years now. And they're, well, almost 50 years now, right? So if you do the math. And so those probes were incredibly well built, very successful. NASA is so happy with their performance. They did a great job building those two. And so the Oort cloud, when Voyager 2 went through the Oort cloud, rocks, ice, comets, asteroids, dust particles, gases, all kinds of stuff that we expect in an asteroid belt, but it's a sphere around. And then around that, the magnetosphere, which is created by our sun, which is a magnetic field that makes these weird bubbly shaped magnetic field lines. And then if Voyager 2 gets outside of that and finds an object orbiting another star, like Proxima Centauri, the next star over, the 4 light years away, nearest solar system to us, if Voyager 2, did I say one? If Voyager 2 gets to the point where it finds something orbiting another star, it will have finally reached the outside of the solar system. However, it hasn't gotten there yet. In 40-something years of traveling through space at incredibly fast speeds, it just hasn't gotten to another solar system yet. Maybe one day, and hopefully hopefully its power core will still be running at that point. All right, so asteroid belt between Jupiter and Mars, Kuiper belt outside of Pluto's orbit, and Oort cloud really far outside that big sphere of asteroids, comets, and other particles. I'm going to call it quits there, and hopefully that will be useful to y'all.